All right, so this formula sheet, usually it'll be the same that you have from year to year. They have combined all of the 6th, 7th, and 8th grade formulas onto one formula sheet, but they have changed a little bit from how it was last year. They changed where some of the shapes were. Last year they had it more grouped by grade level and which shapes you'll use, which formulas you'll use each grade level. This year they've kind of rearranged it so that like all your 2-dimensional shapes are together and your 3-dimensional shapes are together. So it is important to know what you're actually going to be using this year. This year, I'm going to have you kind of like bubble or circle or somehow, however you want to notate it on your formula sheet. You're going to be using these formulas right here. So you have your rectangular prism, you have volume and surface area for that, and then we have our cylinder next to that. And you have volume and surface area for a cylinder as well. So these are your 7th grade formulas that you're going to be using this year. They actually have added 2 more formulas from what they've had in the past. I'm not really going to be focusing on using them because it's just another way to find volume. They did add that volume is equal to the base times the height for both the cylinder and the rectangular prism. What we're going to be using for most of our notes is going to be the first formula listed for each of these. Now, does anybody figure out or recognize which formulas you used last year? Which one were your 6th grade formulas? What do you think? Yep, the one with the rectangle here. You did perimeter and area. What else looks familiar? The square, you did perimeter and area. What else? The circle, you did circumference and area. And with circumference, you did have 2 different possible formulas you could use. One used radius and one used diameter. There's one more that should look familiar. The triangle. So this whole top row, and I have to kind of go make room for everything for that cylinder, but that, or excuse me, for that circle, that whole top row was 6th grade. Everything else I've not like bubbled in or boxed in is 8th grade. Okay, so this row here and then these, the pyramid and the cone, you'll be using those in 8th grade. Okay. For your formula sheet, it is possible for you to see questions on your SOL that are either above 7th grade or below 7th grade. That is because your test you take is a CAT test. That's computer adaptive test. That means if you are getting a bunch of questions wrong in a specific topic, they may drop you down to some 6th grade questions. Make sure you understand that 6th grade concept and keep you from getting frustrated. Likewise, if you do very well on the 7th grade questions, they could give you an 8th grade question just to see if you can figure it out. So it is possible you could have questions where you would be using some of the 6th grade formulas or even some of these 8th grade formulas, but for the most part, this is what we are focusing on this year. Okay? So now that we've kind of like marked that up with what you need to know, now we can flip to your notes page. Okay, so we are finding the volume of rectangular prisms. Your divider, I just had you write volume of prisms, but more specifically, it is rectangular prisms. So the volume of a 3-dimensional figure, we have to know what volume means, okay? Volume of a 3-dimensional figure is the amount of space, that's your first blank right here, that it occupies, how much space it takes up. Another way of thinking about volume is filling the inside of the shape. And because of this, because you're dealing with a 3-dimensional shape, you're figuring out either how much space it takes up in like your 3 dimensions there, like in real life, or thinking of it as how much can fit inside of this 3-dimensional shape. Volume is measured in cubic units. Cubic means dealing with cubes, okay? So you see cubes here. This is a 1 centimeter cube, this is a 1 inch cube. So your 3 dimensions here would be your length, your width, and your height. Altogether, that cube is 1 centimeter cubed, or you could say 1 cubic centimeter. Likewise, this cube, it's 1 inch by 1 inch by 1 inch. So your 3 dimensions, your length, your width, and your height are all 1. And that is either 1 cubic inch or 1 inch cubed. So we use the 3 to mean cubed. Think about it being a 3 because it's 3-dimensional, okay? Now to find the volume of a rectangular prism, we use the formula assigned to the formula sheet, which was length times width times height. They do give you that base times height that you can use, but the length and the width, when you multiply those together, that gives you the area of the base. So together, the length and the width basically make up the base. If they gave you the base specifically, you could use that second formula. Other than that, it's kind of personal preference. There's 2 examples here where we're going to solve for the volume of each prism. Again, more specifically, these are rectangular prisms because each of the sides is a rectangle, okay? And when you are using your formula sheet, you have to look for 2 things. You have to look for what shape you're dealing with, and that's normally the first thing I look for. Because your shape, your formula sheet is broken down by your different shapes, okay? So if you know you're dealing with a rectangular prism, look there first. Then figure out what you're solving, okay? What did it ask us to solve for in that problem? Or in that section? It said to find the what? Volume. So find, like on your formula sheet, the rectangular prism, and then look for the volume formula. So we're going to use volume is equal to length times width times height. Does not matter what you assign as length, width, or height. Again, it's 3-dimensional. What looks like length right now, if I rotate it, could look like the height. So just pick something and go with it. I'm going to make this 9 feet the length for the purposes of this example. I'm going to make the 7 feet the width, just so you can see. I know it kind of looks like that's the height, but just so you can see, it doesn't matter. And we're going to use the 11 as the height for this example. So then you just have to substitute in those values. So we said length is 9, the width is 7, and the height is 11. So you're multiplying together 9 times 7 times 11. So I'll pull up Desmos on the screen as well, just so you can see how different ways that you could solve this in your calculator. One way that you can do it, do you have the answer for me? One way you can do it is to just type in the 9 times the 7 times the 11, and what is the answer? 693. Now for our answer, we have to pay attention to our units. So what units were we dealing with here? Feet. And what am I going to use for my exponent? A 3. So 693 feet cubed, or you could say cubic feet. Now the other way you could enter this into your calculator, and it will probably be more beneficial with some of our other formulas. For this formula, this first way I've shown you is probably the easiest, the least time consuming, but you can actually type in the formula V equals LWH, just like we did with our replacement value. You can tell Desmos what your length is equal to. So L equals 9, your width W equals 7, and your height H equals 11, and then you'd look back up here and you still get the 693. Okay, some of our more complicated formulas, it might be more beneficial and save you time to do it this way, where you type in the formula and then tell Desmos what your different dimensions are, what your variables are. If you're just doing length times width times height, it's probably faster just to type the 3 numbers in and multiply them. But it's, again, personal preference. All right, moving on to our second example here with our picture. So formula that we're using, again, since we're solving for volume and it's a rectangular prism, is V equals length times width times height. For this example, I'm going to make the 8 yards the length, the 4 yards the width, and I'll do the 12.5 as the height. So I can substitute those values in. So you'd have 8 times 4 times 12.5. I will take this moment to kind of draw your attention to be careful with your handwriting. If you are using the dot to represent multiplication, that's fine. It takes up less space. You normally see that more like in higher math. But don't get it mixed up with the decimal point. They should be on different levels. The decimal point should be on the bottom of your numbers. The dot for multiplication should be up in the middle. Okay? Does anybody have that total for me when you multiply them together? What'd you get? 400. Yep, 400 exactly. So 400, what were my units in this example? Yards, and then I will do cubed. All right, so we have a word problem for our next example. This last two examples are word problem form. So you have Frosty Crunch cereal. It comes in a box that is 8.5 inches wide. So that's my width. 11.4 inches high, so that's my height. And then it says 2.6 inches deep. It doesn't, what dimension are we missing? Like we have width, we have height, what are we missing? Length. So this is your length right here. They used a different word that kind of means the same thing. So that is going to be your length. Again, it doesn't matter which hour to assign to what. Essentially, I'm multiplying those three numbers together. It asks, what is the greatest amount of cereal the box will hold? What key word in this sentence tells me that I am solving for volume? I mean, it's on a volume notes page, so we're probably solving for volume. But what key word, if this was not all on a page dealing with volume, would tell us volume? Greatest amount just means you wouldn't want to have any like empty space, which I know in a box of cereal or chips, they never fill it completely to the top. I'm looking for something else. Hold is that keyword that is going to indicate that that's volume. Because one of the ways you can think of volume is how much you can fill inside of it. And what are you filling it with? You're filling it with the cereal. That's how much it will hold. Okay. The other thing that's important, of course, is the shape. What shape is this? Or what word tells me the shape? Box. That tells me that it's a rectangular prism. So there's your shape, and there's what you're solving for. So volume is equal to length times width times height. I plug in those values. Again, be careful with your decimals not looking like time symbols and vice versa. I have 2.6 for my length times 8.5 for my width times 11.4 for my height. And what is that volume? What you got? 251.94. What are my units? Inches, and then we will cube them. And my last example. So you have a cargo space of a tractor trailer that is a prism. So in this case, it's a rectangular prism, if you know what a tractor trailer looks like. It has a height of 9 feet, a length of 28 feet, and a width of 8 feet. The box over here shows the dimensions of the boxes that will be loaded into the truck. The question asks, what is the greatest number of boxes that can be loaded on the truck? So there's multiple parts to this question. What's the first thing I have to solve for? There's two things I have to solve for. What's one of the things I have to solve for? Yeah, the cargo space in the tractor trailer. So if it's how much you can like fill inside that tractor trailer, that's volume. So first thing, I'm going to write tractor trailer. because we want to keep straight, like what's what here. The volume of the tractor trailer, so length times width times height. We're going to plug in the values that we have. So that would be 28 times 8 times 9. Raise your hand when you have that answer. What'd you get? 2016. What are my units? Feet. What goes after feet? Cubed, because it's volume. Then, what's the other thing we have to solve for? Yeah, the volume of each box. So each box same formula, length times width times height. I'm going to make the 4 the length, the W, or the width, I'll make the 3 feet, and the height will do the 2 feet. So when I plug in those values, it's 4 times 3 times 2, which gives me what? Volume is equal to 24 feet cubed. Okay? Now, we have not answered the question yet. We've done the steps leading up to how we're going to answer this question. The question says, what is the greatest number of boxes that can be loaded into the truck? Don't give me the number. Tell me what operation I'm going to do to figure that out. Yes, you're going to divide. So 2016 divided by 24, so the amount of space in the truck divided by the amount of space each box takes up gives me what? Now my units for this is not feet or feet cubed. What are my units? Boxes. It asks what is the greatest number of boxes. Good. So always go back to like rereading the question and just make sure you're answering it.